Good morning. So today we're going to discuss another study that you might be you might use in your research. So let's proceed. Let's start. So assuming this is the title of the study, the comparative study on the satisfaction level of of a certain computer laboratory, and you want to compare the satisfaction level of the business management students, you want to compare the satisfaction level of finance students, you want to compare the HR students, the human resource students. So in this case, our statement of the problem is, the first statement of the problem, what is the satisfaction level on the computer laboratory among BM, finance, and HR students? So that's the first statement of problem. The second, is there significant difference? So after we computed the mean or the median of the satisfaction level of BM, the finance, and HR, we want to know now, is there a significant difference on their satisfaction level on the computer laboratory among those students? Okay, so the hypothesis of this study is there's no significant difference. So the null hypothesis is there's no significant difference on the satisfaction level of computer laboratory among BM, finance, and HR students. So in order to start the assumption, in every test that you want to conduct, always test the assumption first. Okay, you want to test if we're going to need a parametric or non-parametric test. But before that, let's explore our framework. Let's go back to the framework. How many dependent variables do we have in this study? Dependent variables, there's only one. What type of variable is that? Continuous. Okay, how many independent variables do we have? Still, please remember, very important, there is only one independent variable here, which is the course. Okay, and then what type of variable is that? Categorical. And then, if categorical, how many categories do we have? In this particular case, we have three categories, the BM, finance, and HR. So we're going to follow here, more than two. And then the question now is, if categorical, same or different participants? Different or same? In this particular case, if a certain respondent will answer BM as his course, so basically he will not be able to answer the finance because he can only represent this BM here. Hence, we will have different participants for every courses here. So, different participants. Okay, different participants. So, yes or no. So, this is now the very important part. We will now test the assumption for parametric test. If the assumption is met, so we're going to use the one-way ANOVA. If the assumption for the normality and homogeneity of variances will not be satisfied, so we're going to use the Kruskal-Wallis. Okay? So let's start. So assuming that after the data gathering, you will have this data here. So this is the satisfaction level for item number 1. Satisfaction level, siguro this is the ambience, the environment, the computers. Okay? So in order for us to get the overall satisfaction of that certain laboratory, we have to average that items there. So equals, and then the average, and then we have to average this one, and then the course encoded. So here, okay. So you can select this one, ignore course, ignore error. And then for the course encoded, okay, I prefer to do it this way. Okay, and then after that, you paste it again here. And then, let's say for our encoding, we will use that the BM, we will encode BM as 1. And then we will encode finance as 2. Then we will encode HR as 3. So using that legend, highlight all of these, then Control H, and we will select, find what? The BM. We will change that one to 1, replace all, 101. We will also have the finance 2, replace all, and then the HR, replace 3. Okay, so that is our encoding here. Okay, so we will now copy this one here. We'll now copy the satisfaction level and the encoded course in our SPSS. So you go to SPSS, and guys, make sure that you paste it not in the variable view but in the data view. So you right click that one, right click, and then you paste. And then we will now label this one here from our previous discussion. Go to the variable view. This is the satisfaction. Guys, no spaces in the name. So it will not allow having spaces in the name. Satisfaction. And then this one is the course. And then using the legend that we had, the label here, the values here, 1 for BM, 2 for finance, 3 for HR. Okay, and then okay. So after that one, you go back here and then you can click this one. Okay, so first is for us to decide. We only have two options here, the tools that we can use. We can use either the one-way ANOVA or the cross-Wallis. Okay, let's proceed. So how do we test the assumptions? Same as before, analyze. You go to the descriptive, explore, and then we have to change the type of data, the course here. We will change this one to nominal and then the other one to scale. Okay, and then go back, analyze, descriptive, and then explore. So the satisfaction is the dependent list, and then the factor list is on the course. And then statistics, descriptive is good. We go to the plots, same procedure as before. So we will not need the stem and leaf, the histogram, the normality plots, and then for the Levene's test, the untransformed, okay, and then good. Okay, so the data is now processing. So our concern here is the test of normality and the homogeneity of variances. So let's inspect the test of normality. The test of normality, what is our guidelines again? So for the test of normality, if the sig value, so we'll highlight this one. Okay, in order for us to have a clearer view. Okay. So very important, we have to remember, test for normality. If the significance value is greater than 0.05, then the data does not significantly differ from normal distribution. If the sig value is less than 0.05, so it means that the data significantly differ from normal distribution. So let's inspect. The sig value of the BM is 0.6, greater than. The finance is 0.058, greater than. The HR is 0.107, so greater than, also greater than. Hence, we can say that the test of normality for the courses here follows the normal distribution. But wait, there's more. Okay, we have also to satisfy the assumption for our variance. Okay, so we should have also assume equal variance in order for us to we can use the parametric test. So let's inspect. So according to the homogeneity of variance, so based on mean 3.363, if we're going to look at our guide here, if the sig value is greater than 0.05, the variances do not significantly differ from each other or assumed normal. Okay, so this is good since this value is greater than. So the parametric, for parametric, good, okay tayo dito, and then for this one, for the homogeneity of variance, good. So ibig sabihin, if we go back to our framework here, so the data meet the assumption for parametric test. So different, yes, and then we will now use the one-way ANOVA. That is how you decide what statistical tool are you going to use. Okay, if any of these three here, if any of these 1, 2, 3, and 4 here is less than 0.05, hence we will not, we cannot use the ANOVA. We will proceed with another test called the cross-Wallis. Okay, but since the assumption for normality and homogeneity of variance was met, so let's proceed. But before we proceed, we would like to edit it first here. So the assumption for normality, I would like to advise you to put the table here, right click, and then copy. If for some cases that you will not be allowed to copy as picture. You cannot paste a picture. You can use the snipping tool, and then just click this one, and then you snip the test of normality here. You can snip that one. Just press Ctrl C on your keyboard, and then just paste it here, the test of normality. Okay, so that we will have a guide. And then the other one here, you go back to the tab, and then we have to paste the homogeneity of variances. So again, Ctrl N, or you can press the new here, and then just copy this one, click, and then on your keyboard, Ctrl C. And then you go back to the Word file, and then the homogeneity of variances, Ctrl paste. Okay, so in this case, let's now, we can move the homogeneity of variance in the next page. So in this case, we can now change the discussion here. The satisfaction level, so based from this result, the satisfaction level of BM, D, this is for the Kolmogorov-Smirnov parameter, D, and then this one is the degrees of freedom here, the 1112. Oh, in this case, BM, in this 1112, so that is the D here is degrees of freedom, 101, and then the value, the statistic is 0.86, and then the p-value is greater than 0.05 for finance. The degrees of freedom is 131, and then the statistic is 0.76. Okay, the p-value is greater than 0.05. The p-value is greater than 0. For HR, the degrees of freedom is 99, and then equals, and the statistic is 0.081, and then the p is greater than 0.05. Do not significantly differ from normal distribution, because all of the values here are greater than 0.05. So let's proceed. For the homogeneity of variance, for the level of satisfaction, the variances were equal, because based on this one here, the F, and then the first degrees of freedom number 1, degrees of freedom number 2, 382, equals the Levene's test, 1.02, and then which is the P is greater than 0.05. So the discussion here, since the satisfaction level for BM, finance, HR students are normally distributed and have equal variances, hence the researcher used independent ANOVA, or analysis of variance. Okay, so in order for us to proceed, let's proceed to the ANOVA. How do we perform the ANOVA in our SPSS? So analyze, we will go to the compare means, and then we will do the one-way ANOVA. Just click that one, and then drag the dependent list of here, the satisfaction, and then the course here under the factor. And then we will also do here a post hoc. A post hoc is very important, especially if there's significant difference in the result, because we will be able to see what particular factor or what particular item na significantly differ among the others. We will see later on. So for the post hoc, we will use the Tukey, and then okay, since the equal variances here, equal variances is assumed, we will use the Tukey. Okay, Tukey, equal variances, because based on our result, the homogeneity variances, we assume that the variances are equal. So we will click this one. We can also click this one, but in this case, we will only use the Tukey. And then continue, and then set the options. Okay, so means plot if you want. You can have the means plot. You can have the descriptive. Homogeneity of variance, no need to click this one because we already performed the homogeneity of variance. And then just press OK. Okay, so this is the descriptive. This is very important here. This is very important. So, yeah. So if we're going to take a look at the results here, the first thing that we have to do is we will proceed with the descriptive. The descriptive here states that The BM, the satisfaction level for BM is 7.1. The satisfaction level for finance is 4.7. And then the satisfaction level for HR is 7.2. And then the question now is, so, is there significant difference is there any of these mean here significantly differ from each other? So if you're going to look at the ANOVA here, ANOVA, this is the result of our ANOVA. We can also cut this one, paste this one here, this portion here. But in this case, the values are wrong. So we will do the snipping tool, Control N, and then copy this one. We can copy that one, Control C, then you go back to the Word. We can delete that one, and then just paste it there. Okay. Okay, and then, yeah, and then for the ANOVA here, the ANOVA states that 0.0. What does it mean? If 0.0, there is a significant difference. At least one. Ibig sabihin yan, at least one of the items there significantly differ from each other. Okay? So if we are going to have the 0.0, how are we going to reflect that one in our hypothesis? If we go back to the ANOVA here, so what is our decision for our hypothesis? So our null hypothesis is there is no significant difference on the ANOVA since the value of this is a significant value is less than 0.05. Hence, we can fail this one. We can reject. We can reject this hypothesis here. We can reject it here. We can note that we will reject the hypothesis here. Why do we have to reject? Because the significant value is less than 0.05. And then how do we know? How are we going to know if which among these BM, finance, and HR? So based on the mean, we can directly say that the finance is very much away from the mean of BM and HR. So if you're going to do the post hoc analysis here, so how do we do this? So in order for us to analyze the post hoc analysis, we are going just to see to look at this value here. So this is the BM compared to finance, BM compared to HR, BM compared to finance. Is there a significant difference? You go to the SIG. Yes, there is a significant difference between the response of BM and finance. BM and finance. And then how about BM and HR? There's no significant difference because the significant value is greater than 0.05. However, very similar to this case, since the BM and finance here is 0.0, of course, the finance and BM 0.0 again. Okay? And then the finance and HR 0.0. So basically what the table is trying to say here is that the finance value here, the mean satisfaction level of the finance students significantly differ from the satisfaction level of BM and HR. So that's very, very important. Okay, so if we're going to look at this portion here, so this portion here states that the satisfaction level is this one. This is the mean, 4.72, and then the mean. So the group here is for BM and HR, so they belong in the same group, and then the finance significantly differ. If we're going to see the means plot, so the mean for the BM is around here, and the mean of the HR is around here, and then the finance is very low. Very low. The satisfaction level of the finance students is very, very low. So how are we going to put that one in our conclusion? In our conclusion, tool, so this is the descriptive, and then we will now post the ANOVA here. Delete table, and then we need to post this one. So the snipping tool, Control N, or you can click the new there, copy, and then we paste the result of the ANOVA here. Okay, and then for the post hoc analysis, and then guys, a reminder, you will not do post hoc analysis if the result of the ANOVA here is greater than 0.05. You will not do post hoc kasi there's no significant difference among the responses. So why do we have to do the post hoc? You will only do the post hoc if the significance value, if there is a significant difference, if at least one of the means there significantly differ from the group. Okay, so for the post hoc here, let's post the result, the post hoc. So this is the post hoc analysis, and then new, copy this one. Okay, and then we will just paste it here. Okay, and then if you want, for simplicity purposes, you can also copy the means plot. The means plot to have a visual presentation of the means plot. Okay, so the conclusion here, on average, the satisfaction level on the computer. So how? Okay, so give me a second. I will rephrase this one. Okay, so let's continue. So on average, the satisfaction level on the computer laboratory for finance here, the mean is 4.72, is lower than BM. The M here, this is for the BM, and then the HR is here, BM. The result shows that the satisfaction level of finance students significantly differs from the satisfaction level of BM and HR students. So we will now proceed to the business implication. So what is the implication here? So probably finance students found it they're not satisfied with a certain computer laboratory, and then the question is why? Why are the finance students not as satisfied as the BM and HR students? So we can conduct another survey, qualitative survey about that, or quantitative survey about that, to identify the factors why the satisfaction level of the HR students, of the finance student differs from the other students. Okay, so that's it. So next activity, we're going to explore another statistical tool. Okay, thank you.